Hello, my dear students. Welcome to IMS GATE Academy. I hope you are really excited, and I have seen the message from Deepak that he is waiting for the class. Okay. Hello, my dear students. Today I would like to tell you one important thing. Okay. Please be on one second. I will start. Hello, students. Sorry. Welcome to IMS GATE Academy. Myself, Sandeep Adari. I have done my BTech from JN2 Hyderabad and MTech from NITs Surathkal with A rank 192. I have a teaching experience of around 10 years in the field of GATE coaching. I am really excited to see the message from Deepak. Good evening to all. I hope you are doing a productive preparation for the GATE as we are inching towards the close to the exam. So everyone, I would like to tell you one important thing, Amma. You have to utilize the time in an appropriate way. So IMS GATE Academy has come up with a capsule called GATE Booster. So in this GATE Booster, we are trying to give you the concepts in such a way that through the problems. So each concept will be explained through the problems. So good evening Chandu, good evening Atul sir. Thank you Ankit Dongrial. Thank you sir. Thank you Saro sir. Sir, students, now today what I would like to tell you is I would like to focus more on pre-stressed concrete, but we are left out with some of the topics related to RCC also. We will be covering that topics also. So my dear students, as part of this, first question I would like to discuss here is, please read the question, my dear students. For M25 concrete with creep coefficient of 1.5, what is the long-term static modulus of elasticity? So my dear students, here is asking the formula for long-term modulus of elasticity. Now my dear students, what is long-term modulus of elasticity? So here I have a very important thing here, my dear students. Here, what is long-term modulus of elasticity? Can anyone tell me what is long-term modulus of elasticity? Long-term modulus of elasticity is given by the formula, or I am writing long-term modulus of elasticity. The long-term modulus of elasticity is given by the formula. Can anyone tell me? My dear students, we have EL, that is long-term modulus of elasticity is equal to short-term modulus of elasticity upon theta, 1 upon 1 plus theta. What is long-term modulus? Short-term modulus upon 1 plus theta. See here, my dear students, he has given the creep coefficient, that is theta, and he has given the grade of concrete as M25. The grade of concrete is given how much, my dear students? The grade of concrete is given as M25. Am I clear, my dear students? So the grade of concrete here we have is M25. So you know theta, but do you know the short-term modulus of elasticity? No. Sir, my dear students, in the previous code, short-term modulus of elasticity says that 5700 root FCK, but the present code says that the short-term modulus of elasticity is given by the formula 5000 root FCK. My dear students, this is an important formula. Please remember this. So, my dear students, what is the short-term modulus of elasticity? It is given as 5000 root FCK. What is FCK? FCK is nothing but characteristic strength of concrete. What is FCK? Characteristic strength of concrete. So, when I talk about this, the short-term modulus of elasticity is given by the formula 5000 root 25. That is, the grade of the concrete is how much, my dear students? It is 25. So here what is the value you will be getting is the short-term modulus of elasticity is given by the formula 25,000 Newton per mm square. So my dear students, please understand that The short-term modulus of elasticity is 5000 root FCK. So what is FCK? Characteristic strength of the concrete, my dear students. Now, my dear students, what is the unknown we have? Unknown is theta. What is theta, my dear students? Theta is nothing but creep coefficient. There was a previous GATE question also, what based on creep coefficient. What is creep coefficient, my dear students? Creep coefficient is defined as the ratio of ultimate creep upon elastic creep. What is creep coefficient, my dear students? Thank you, Vijay Agarwal sir. What is creep coefficient, my dear students? Creep coefficient is defined as the ratio of ultimate creep by elastic creep. What is ultimate? The maximum. So it is the time. It is the ultimate time for you also, students. You have to start preparing. You have to focus. Focus is very important in GATE exam, my dear student. So what is the theta value here? Theta value is given as 1.5. So when I talk here, long-term modulus of elasticity is given by the formula short-term modulus of elasticity upon 1 plus theta. So short-term modulus of elasticity you have calculated as 25,000 upon 1 plus theta. Theta is directly given, my dear students. What is the theta value, my dear students? 1.5. So if you divide this, you will get a value of 10,000 Newton per mm square. Remember, my dear students, the modulus of elasticity units and the stress units will be same. The modulus of elasticity and stress units will be same. So I hope you are clear. So this kind of question, my dear students, I would like to tell you very simple way. They can ask you the short-term modulus of elasticity, that is 5000 root FCK, or they can ask you the long-term modulus of elasticity, that is short-term modulus of elasticity upon 1 plus theta. These two things they can ask you, my dear students, and they can twist on theta also. What is theta is? Theta is the ultimate creep upon, or we call theta as the creep coefficient. What is theta, my dear students? Theta is nothing but the creep coefficient, and theta is defined as ultimate creep upon elastic creep. I hope you are clear, my dear students. Is it clear? Can you please respond in the chat? Is it clear, my dear students? So there can be 3 questions asked from this problem. I hope I have covered every topic in this. Now, this is a beautiful question. Sir, remember, my dear students, this is one of the beautiful question I am looking forward. So what is the concept here? According to the concept of limit state design, according to the concept of limit state design, as per the IS 456, the probability of failure of a structure. So very good. Thank you, Chandu. Thank you. Sir, what is probability of failure of a structure? What is probability of failure? Great answer, great answer. Ignited mind, your small change is there, but it's a very good answer. Very good answer, ignited mind. So what is this probability of failure structure? What is the probability of failure structure? Sir, remember, my dear students, when you design a structure as a civil engineer, my dear students, safety is very important. We ensure that safety is important. Like what we feel is shelter is one of the basic need and life is very important. So everyone will take safety as priority. So when you design a structure, you take safety as highest priority. So when is the probability? Is the probability high or is the probability low? So that's what I would like to tell you here. Now see, students, here, when I talk about the design load, my dear students, when I talk about design load, or they can give you design load or characteristic load. Sir, actually when I talk about characteristic load or design load, if you take characteristic load, if I take characteristic load, okay, if I take characteristic load, what is characteristic load? Can anyone tell me? What is characteristic load? Good evening, Jagdish, good evening. What is characteristic load? What is characteristic load? Sir, remember the word characteristic load means it is the load at which 95% of your test results are passed. Good evening, Shashikant, good evening. So what is characteristic load, sir? Characteristic load is something like where 95% results are passed. Sir, if you are getting 95% results passed means how much is the probability of failure? It can fail 5%. So the probability in case of load, if you take here, it is fail. So you can take 5% as fail and 95% as passed. One is related to what, sir? Load. Similarly, if you talk about strength also, my dear students, okay? If you talk about strength also, what is the strength value? The strength also 95% it will pass and only 5% it will fail. So the probability of failure, what is the probability of failure, my dear students? The probability of failure is 5%. So 95% it will pass. Now I will tell you one thing. Sir, see students, there can be three cases. One, load fail. There can be a load failure. Strength can be passed. So we have to consider three cases. There can be a load failure, strength can be passed. Another one, strength failure or load is passed. Are you getting, my dear students? Can you respond? Or the third case is both strength and load can fail. Both strength and load can fail. Am I clear, my dear students? Is it clear, Amma? So we have come up with three topics, Amma. What are the three topics? Load will fail, one case, and strength will pass. Another case is strength will fail, load is going to pass. The third case is both will fail. My dear students, when we talk about mutually exclusive events, you might have studied in your sets and theory. Mutually exclusive events means they won't have any intersection. So when I talk this condition, when load is failed, what is the probability of failing load? So what is the probability of failing load? So I am starting the answer, Amma. What is the probability of failing load? Anyone? Can you please respond? It is 0.05. Right? The probability of failure of load is 0.05 and the strength will be passed 95%. Similarly, the probability of strength fail is 0.05 and the probability of load pass is 0.95. Okay, and both strength and load will fail. That is 0.05 multiplied by 0.05. So what is the answer, my dear students? I am really waiting for your answer, students. So first case is load fail, strength pass. Strength fail, load pass. Both are failing. What is the answer, my dear students? Some of you have told already ignited mind. Can you check the answer? Good evening, sir. Nikhil Gaurav, sir, is one of the best faculty for machines. He is associated with IMS GATE Academy. You can follow his machines classes also. So, see here, my dear students, what I would like to tell you is the probability of failure of a structure depends on three cases. Load fail, strength pass. Strength fail, load pass. Both strength and load will fail. So, what is the answer? Ignited mind. I am waiting for your answer. Jagadish, anyone? Can you please respond? Okay. So the answer is 0.0975. It is 0.0975. Great, Prashant. Great. So remember, my dear students, I will ask you one important thing here. The probability of failure is 0.0975. Then what is the probability of passing? What is the probability of passing? So if you take two events, you might have studied in your mathematics, my dear students. If A is going, remember that both events pass and fail. Probability of pass plus fail should be equal to 1. So the probability of failure is 0.9. You can say 9.75 percentile because it is divided by 100. sorry, multiplied by 100. If I take it multiplied by 100, it is 9.75 divided by probability of pass. Sorry, when you add probability of pass plus probability of failure is equal to 1. What will be the probability of pass, my dear students? It will be equal to 91.25. So, according to the limit state theory, what is the probability of passing a structure? Oh, sorry. Okay, sorry, sir. Correct me. 90.25. You are correct. You are correct. Sorry. Thank you, Ignited Mind. Thank you. Thank you. Ankit Dongrial. Thank you, sir. Okay, thank you. Thank you. So, what is the answer here? We have 90.25. Agree, sir? So, remember what is the probability of failure. So, you can remember this also, ma. These kind of questions will be coming in IES 1 mark question also. What is the probability of failure of a structure? You can say 9.75%. What is the probability of passing a structure? Is 90.25. So, we have covered both failure of a structure and the probability of passing it. Sir, what do you mean by passing? Probability of safe. Again, don't ask me. If they ask you in the question, what is the probability of safety of a structure, means it is 90.25. Okay, sir. Thank you, Ignited Mind, and thank you, Ankit. Pardon me. Okay. Now please read this question, my dear students. Please read this question. A varying depth or hunched. This is a very beautiful question also. A varying depth reinforced concrete beam is simply supported at both ends. You might have solved in strength of materials also, my dear students. The beam is subjected to a uniformly distributed load of 10 kilonewton per meter. What is the design shear force? What is the design shear force? So, my dear students, I will tell you in a simpler way, amma. For a varying section, design shear force or the design shear force is given by the formula Vu plus or minus m by d tan beta. For the varying section, write down, my dear students, for a varying section, the design shear force is given as shear force plus or minus m by d tan beta. It is given by what, my dear students? It is given as shear force plus or minus m by d tan beta. Now, I have a small question, my dear students. When do you go with positive sign and when do you go with negative sign? Students, my intention is not solving only this problem. You should be clear if any question is asked in and around this concept. That is the main agenda. So, when do we go with plus and when do you go with minus? See, students, here as the depth is increasing, I will tell you a small problem, small example. If I consider a simply supported beam, the bending moment is, okay, the bending moment is maximum at center and minimum at ends. If I take a cantilever beam, my dear students, the bending moment diagram is maximum at fixed end. The maximum at which end? Fixed end. Here it is minimum at supports. So, in simply supported beam, the bending moment is minimum at supports, whereas it is maximum at supports. This is for what, my dear students? This is for cantilever beam. This is what for, my dear students? This is for cantilever beam. So, my dear students, what do you mean when I talk about cantilever beam? So, when I talk about cantilever beam, a beam which is fixed at one end is called cantilever, and a beam which is supported at both ends is nothing but the simply supported beam. So, here please observe this carefully. If you can understand this concept, my dear student, this problem solving is very, very easy. I promise you this. Now, my dear students, what is the depth here? The depth is 400 mm. And what is the depth here? The depth is 600 mm. So, my dear students, as the depth is increasing, as the depth increases, moment is decreasing. So here I am writing it here only, as the depth increases, I am showing with upward arrow, increases. What is happening to in simply supported beam? Moment decreases. I am showing with downward arrow. As depth increases and moment decreases, what will happen, my dear students? What will happen to the, we will use, or I am writing again here, sir, as depth increases, as depth increases or moment decreases, we use positive sign. We use which sign? We use positive sign. Agree, my dear students? Agree? Now, increases, sir. Okay. Now, as depth increases, moment increases. Moment increases. Now I will tell you, Amma. Suppose this is a cantilever beam. This is a cantilever beam. Okay? You are having depth here less. Here depth is increasing. But moment will be maximum at where? Moment will be maximum at fixed end. So in this case, you will take negative sign. In this case, you will take negative sign. But if you take the best example, that is simply supported beam, where the depth is increasing, the moment seems to be minimum at supports. In this case, you will use positive sign. You will use what, sir? You will use the positive sign. Am I clear, my dear students? Now see, students, what I would like to tell you here is, there is a simply supported beam. Okay, there is a simply supported beam. Sir, here it is a varying section, right? It is a varying section of simply supported beam. Okay, now see here, the load is how much, my dear students? What is the load here? 10 kilonewton per meter. What is the distance between the spans? The span is 20 meter. The distance between the span is 20 meter. Am I clear, my dear students? So here, if I take the distance, this is 10 meter, because it is also 10 meter. And we have, my dear students, this is 400 mm. And this depth is 600 mm. This depth is 600 mm. Now, my dear students, Naresh Chauhan sir, I have TPSC AW exam in Jan 22. Suggest sir how to utilize time period. Your suggestion. Naresh Chauhan, actually I am having TSPSC AW exam in Jan. Naresh, as far as I know, sir, remaining students, even it is out of topic, I'll just give my 2 minutes of time to, or 1 minute to Naresh, because it's an important question and this is a very important notification also. Naresh, what I will tell you is, first concentrate on strength of materials and fluid mechanics. One paper will be on strength of materials and fluid mechanics, and you have to go through the IES 1 mark questions. If you go to the IES 1 mark questions, that kind of level you have to prepare. You need not to prepare gate level, because for AW exam, the questions will be mostly from the prelims of IES. I am not telling they will come exactly, but that time will be. And remember, for every subject, you have to give some time for based on the marks. Like SOM and fluid mechanics, you give every day 1 hour of time. 1 hour for SOM and 1 hour for fluid mechanics. Another 2 hours for your remaining subjects and 2 hours for your non-technical, that is general studies. Okay, and Naresh, you can get in touch with IMS GATE Academy in the website and you can ask all your doubts. Okay, I'll reply you in that there. As far as now, utilize the time in this way, that will help you. I hope I have answered your question. Don't neglect general studies also. It is also very important. Apart from general studies, please concentrate on strength of materials, fluid mechanics, and also geotech, transportation, and environmental. But construction technology and management from CPM and PERT, you will get most questions. Try to prepare the previous IES questions, that will help you. Thank you. I hope I have answered your question. Pardon for the remaining students, even though it is an out of box question, it's my duty to explain him, because he is asking a question related to AW. Okay, my dear students. So what is the total load here? Sir is asking what is the design shear force at a section X which is 5 meter. Which is 5 meter. Agree, my dear students? Agree? Agree. So here, when I talk about what is the total load, my dear students, it is a symmetrical beam. So when you talk about the total load, you can take unit load per meter multiplied by the length of the span, that is 10 kilonewton per meter into length of the span is 20. So it will be equal to 200 kilonewton. It will be equal to how much, my dear students? 200 kilonewton. As it is a symmetry one, you can take at the reaction at the supports. If I take this as A and this as B, this will be equal to 100 kilonewton. 100 kilonewton. Am I clear, my dear students? Is it clear, sir? Is it clear? Okay. Now, what is the shear force at the section X, 5 meter? Do you know the shear force? Shear force at XX is given as, when I take upward force as positive, what is the upward force, my dear students? 100 kilonewton minus, what is the load where you are calculating shear force, my dear students? You are calculating the shear force at 5 meter. So, minus 10 kilonewton per meter into 5. So, what will be the shear force at X? The shear force at X will be 50 kilonewton. Am I correct, my dear students? The shear force, very good ignited mind, very good, sir, very good. Okay, the shear force at X is 50 kilonewton. Now, what is the moment, my dear students? What is moment? I will take clockwise moment as, see, my dear students, if there is a reaction here 100 kilonewton and there is a UDL here and we are asking at a distance 5 meter from this because we consider this as XXX. So, what will be the moment? Anyone, my dear students? If I take clockwise moment as positive, so moment will be taken as 100 into, what is the distance? What is moment? Force into distance. Very good ignited mind. 100 into 5 minus, this is 500. And the unit load is how much, Amma? Unit load is 10 kilonewton per meter. So 10 into 5. This is the total load. This is the load. And this load is supposed to act at its center. That is equal to 5 by 2. So 500 minus 125 is 375 kilonewton meter. My dear students, please write the units carefully. Am I clear? Now, my dear students, if you see the question here, if anyone asks you, what is the beta value? What is this beta? They can ask you, what is the beta value here? This we call it as beta. So, what is beta? Here we have the formula tan beta. So, tan beta can be written as what? Here the total depth is 600. Here the depth is 400. So, what will be this depth, my dear students? What will be this depth? This will be equal to 200 mm. And this length is how much, sir? This length is 10 meter. My dear students, it is 10 meter and mm. So, you have to calculate here the tan beta value. So, what is the tan beta value, my dear students? What is tan beta? So, tan beta will be equal to 200 mm divided by 10,000. So, this, because this is in mm, my dear students, there he has given 10 meter, but to convert into mm, 1 meter is 1000 mm. So, tan beta value will be equal to 0.02. And now you have told me that the design shear force is given by the formula VU, shear force at XX plus MU, M by D into tan beta. Now why, sir, see, I have taken positive sign because as the depth is increasing, the moment is going to decrease. As the depth increases, moment decreases, we are going to use the positive sign. So what is the shear force here, my dear students? The shear force here is 50 plus, what is the moment? 375. The moment is 375. And what is the effective depth? This is very, very important, my dear students. This is very, very important. Now, what is the depth? Because these kind of problems, the depth at XX is 5 meter. Here it is 400. Here it is 600. Just by symmetry. Just by symmetry. Ignited mind, check it once the design shear force. You are wrong. So why? Because you have taken the depth wrong, it seems to be. Okay, sorry to say that. Okay, my dear students. So what I would like to tell you here is, what is the depth at XX? That is 5 meter. At 0 meter it is 600. At 10 meter it is 400. What is at 5 meter means? Take the average. Take the average, my dear students. Take the average. So the depth is nothing but 600 mm plus 400 mm divided by 2. Sir, actually not average, sir. I should say interpolation. So you can take 500 mm. So that will be equal to how much, my dear students? It will be equal to 0.05. So 300 divided, depth is 0.05. Again, don't ask me, my dear students, sir, why you have written in 0.05? Because the units of moment are in kilonewton per meter. Because the moment units are kilonewton per meter, you should substitute D also in meter, so that the actual answer will be coming in kilonewton. So what is tan beta, my dear students? Tan beta is nothing but 0.02, which you have calculated here. Now tell me what is the answer. Now ignited mind, you might have taken wrong depth. That is the reason you might have problem. Now what is the design shear force? What is the design shear force, my dear students? Quickly. Quickly. Very good, very good, very good, very good. 65 kilonewton. 65 kilonewton. What is this? 0.05, 375 into 0.025. This will be equal to how much, sir? This will be 2.5. So here we'll get, sorry, sir, sorry here. Here it is not 0.5, Amma. It is not 0.05. It is, 1 second, my dear student. 1 second, sorry. Sir, you should tell me, sir. Sometimes we should not do this. Sorry for that. Okay. Okay, my dear students, 500 mm is what? It is not 0.05. It is 0.5 meter. It is 0.5 meter. Okay. So 375 upon 0.5. This will be 0.5, 750. 750 will be 0.07.5 into 2. Yes, yes, yes. So what is the total shear force? The total design shear force is 65 kilonewton. Remember, my dear students, this concept, how you have done the design shear force, this design shear force you will be adopting in the nominal shear stress condition. I'll tell you. Actually, when you talk about tau V, that is nominal shear stress, when in case of shear force design, we calculate it as what, Amma? VU by BD. But if they ask, this is for uniform depth. If they ask you for varying depth, if they ask you what is the shear stress for varying depth, then you have to remember, my dear students, tau V is equal to VU plus or minus M by D tan beta upon BD. So what is stress, Amma? What is stress, my dear students? Stress is nothing but force upon area. So this is, and one more thing, students, here this VU will be replaced by VE. I am telling you that concept also. The shear force will be replaced by equivalent shear in case of torsion. If there is any torsion, my dear students, equivalent shear will be also calculated. Equivalent shear is equal to shear force plus 1.6 TU by B. 1.6 TU by B. This is the formula for when there is a torsion, you will have additional shear force. Now, my dear students, there can be a question asked, sir, how you can avoid torsion? My dear students, torsion, some part will be taken care by the shear. If the torsion is high, then we provide closely bars. We will reduce the spacing. That is the best way to avoid the torsion. My dear students, if you ask me what exactly is the difference between moment and torsion, torsion, when you do cranking, when you are doing cycling, when you are doing cycling, that crank wheel is nothing but torsion. A torsion is which is occurring along a radial direction. Movement is occur along a plane, occurring in a plane perpendicular, means force into perpendicular distance in a plane, we will talk about movement. When it is in a radial motion or when you talk in polar coordinates, then we talk about the torsion. What is the point I would like to understand from you, my dear students, is equivalent shear is given by the formula shear force plus 1.6 Tu by B. When the shear force is more, then you will design more steel for secondary reinforcement. And remember how much it has been added is 1.6 Tu upon B. I hope you are clear. Is it clear, my dear students? Quickly answer me. Now, please see this question, my dear. This is a simple question. I want everyone to look at this question and try to understand. First, read the question, my dear students. A singly reinforced beam section is shown in the figure. Okay, is shown in the figure, not drawn to the scale. Okay, that's leave that point. Is made up of M25 concrete and Fe 500 grade of steel. And Fe 500 grade of steel. And the cross-sectional area of steel is 942 mm square. As per the limit state of design, the design moment capacity of the section is. The design moment capacity of the section is. Sir, what is moment? Can anyone quickly tell me? What is the design moment, my dear students? The design moment is given by the formula 0.36 FCK B into XU. So what is 0.36 FCK B into XU? This is nothing but what, my dear students? This is nothing but the compression force. This is nothing but the compression force. And we have the next one we have is the lever arm. What is lever arm, my dear students? Lever arm is nothing but D minus 0.42 XU. What is lever arm? Lever arm is nothing but D minus. So compression force into lever arm will give you the design moment. So please try this question, my dear students. Can anyone try this? I will give you 2 minutes of time. You know now what is lever arm and what is compression force. Is it clear? Is it clear, my dear students? 0.36 FCK BXU into lever arm is D minus 0.42 XU. Okay. Now, first of all, whenever this kind of question is asked, first you should say that compression force is equal to tension force. First you should find out the depth of the neutral axis. First you have to find out the depth of the neutral axis. Once you find the depth of the neutral axis, you will get an idea whether it is under reinforced or over reinforced. Based on the depth of the neutral axis, we do this. So what is the value you get? 0.36 FCK B into XU is equal to 0.87 Fy AST. Am I clear, my dear students? This is the one you will get. So what is XU here? What is XU? XU is equal to 0.87. What is Fy, my dear students? Fy is nothing but 500, right? AST is also given. Can anyone tell me what is AST? AST is nothing but 942 mm square. AST is nothing but 942 mm square divided by 0.36. What is FCK, my dear students? Can anyone tell me what is FCK? FCK is nothing but M25 concrete. So FCK is 25 into width of the section. What is the width of the section? Sir, FCK is M25, grade of steel Fe 500, area of steel 942. And what is the one we are having? What is the width of the section, sir? The width of the section is 300 mm. The width of the section is how much, sir? 300 mm. Can anyone quickly tell me what is the answer? I'm waiting for your answer. Quickly tell me, Amma. Just solve this. How much you got, sir? How much you got, my dear students? How much? Very good, sir. Very good. Very good. Very good, Prashant. Very good. You are very fast. Sir, it is 151.76 mm. Sir, I will tell you the shortcut how to do this problem also, my dear student. If you ask me how to solve this problem, Sir, 0.36, 0.87. If you do this, it will be around 2.5. 2.5 into 20, it will be 500. Sorry, 20 into 2.5 is 50. 50 into around 3.1. 50 into 3.1 is nothing but around 151. Sir, MU limit, no need to find out MU limit. Ignited mind, I'll tell you, wait. That is difficult, Amma. Why you are using that? Sir, XU is how much, my dear students? XU is 151.76 mm. Now, my dear students, how to calculate XU max? Sir, I told you clearly, if it is FE250, FE250, what is XU max value, Amma? Can anyone tell me quickly? Quickly, my dear students. 0.53D. If you ask me, FE415, FE415, what is the value? 0.48D. If you ask me for FE500, what is the value? The value is 0.46D. But now which value you have to take? You have to take the value of 450. You have to take the value of, 500. So it will be 0.46D. So XU max is how much, my dear students? It is equal to 0.46D, my dear students. What is XU max, my dear students? XU max is given as 0.46D. And what is the depth, my dear students? Depth is nothing but 450. Sir, depth is nothing but 0.46 into 450. Again, if you ask me how to do this without calci, anyone tell me? Sir, 0.5 of 450 is half of 450, 225. 225 minus 18, it will be around how much? 207 mm. Am I correct or wrong, my dear students? What is half of 450? 225. And what is 4 times of 4.5? 18. 225 minus 18 is 207. Am I correct or wrong? Can you quickly answer me? What is the answer, my dear students? What is the value of XU max? What is the value of XU max? Can you please tell me? What is the value you got, my dear students? Am I correct? Is it clear, my dear students? So this will be equal to 207 mm. So here, my dear students, I would like to tell you XU is less than XU max. Whenever you tell, my dear students, when XU is less than XU max, then immediately as a designer, you should be happy, sir. As a designer, you should become Salman Khan or Rajnikant. Why? Because you need not to redesign. If it is a over-reinforced section, you have to go with, again, design. So when XU is less than XU max, what happens here is, when XU is less than XU max, my dear students, you should understand that the section is under-reinforced. When the section is under-reinforced, my dear students, I would like to tell you one important thing. Whatever the formulas, whatever the design is correct. So similarly, now what we can do is, so the design moment is given by the formula 0.36 FCK B into XU into D minus 0.42 XU. Can anyone tell me, Amma? Can anyone tell me? Sir, see, if someone will feel that this is hectic equation, you can also use this equation 0.87 Fy AST, because both we assume that same. This is tension force and we have the lever arm is D minus 0.42 XU. Sir, I will use this formula to be very specific. 0.87 into Fy is how much? What is the grade of steel? Yield stress of steel is 500. Area of steel is how much, my dear students? What is area of steel? It is 942 mm square, Amma. It is 942 mm square. Multiplied by D is 450 mm minus 0.42 into XU. What is XU, my dear students? XU is nothing but depth of neutral axis, which you have calculated. How much, sir? How much you got? 151.76. So if you want, this is 151.76. So can anyone tell me what is the answer, sir? What is the answer, my dear students? I am waiting for your answer. Sir, this is tension force. This is lever arm. So I'll give you 1 minute of time. Quickly calculate it. Please quickly answer me. Very good, very good, very good, very good, Prashant. Any other answer? Have you everyone got the same answer? This is equal to 158.27 into 10 power 6 Newton per mm, and that value will be equal to 158.27 into kilonewton meter. Sir, again I will tell you without using the calci how quickly we can do. Sir, 450 minus 0.5, 0.4 of 150 is 60. So it will be around 390. So 390 into 942 into 500. How I will do? It should be expressed in 10 power 6. So point here, point here, point here. So 5 into 9.5, it is 47.5. 47.5 into 4. 47.5 into 4 is nothing but that is 30, 190. This will be 190 and 190 into 0.87. 190 into 0.87, if you take that, you will get around 175. Sorry, it will be around 175, but the roughly answer we are getting 158.27. So this how you should get an idea, Amma, because again and again I am telling you, my dear students, when your calculation is fast, as we are moving in a competitive world, each and every point you should be clear. How to use the virtual calci, how to manage the time, how to pick up the questions. These are very important. So is the design moment clear for everyone? And remember, as we have checked XU less than XU max, no need to check the limiting moment. This is fine. Is it clear, my dear students? Is it clear? Is it clear? Students, quiz, quickly response, Amma. Every faculty in IMS GATE Academy is really excited to deliver the gate booster map. So how this will be success is when you share this information to all the friends. And this motto of this gate booster is to educate the students related to the concepts very clearly through the best examples. That is the motto of gate booster. So I hope you are following, and we'll move on to the next question. So can you please see this question, my dear students? Can you please see this question? Please read this question, my dear students. I'll give you 2 minutes of time. I want everyone to read the question perfectly. Okay, my dear students, see here. The question here is, assume a straight line instead of parabola. Sir, actually, if you see the stress strain curve of concrete, it is actually parabola. But he is telling, instead of this parabola region, he has assumed a straight line. That's what he is telling. And this as given, and the partial safety factor of concrete. What is the partial safety factor of concrete, Amma? Is 1. Sir, actually the actual partial safety factor is, or actual factor of safety for concrete is 1.5. So here he has given the stress also. The stress is given as 0.767 FCK. Okay. Now, what he is asking is a rectangular under reinforced concrete section. Sir, he has clearly told that it is a rectangular under reinforced concrete section of how much, sir? Width 300 mm and effective depth 500 mm is reinforced with 3 bars of Fe415 grade, is reinforced with 3 bars of Fe415 grade, each of 16 mm dia with a mix of M20 concrete. Now what he is asking is, what is the depth of the neutral axis? What is the depth of the neutral axis? And the depth of the neutral axis obtained as per IS 456 differs from the neutral axis obtained in the above equation is. Is the question clear, sir? From the question, it is evident or clear that the stress strain curve of concrete has been changed. Usually, as per the code of IS 456, we assume the stress strain curve of concrete as rectangular parabolic, but in this problem he has assumed that the stress strain curve is linear and straight line. Instead of parabola, he has assumed as linear. That is the first point I would like to tell you. The second point which I would like to add here is the stress strain curve, the partially safety factor for concrete is, as per the IS code, is 1.5 amma. But here he has taken a value of 1. He has taken a value of 1. Am I clear, my dear students? Am I clear, sir? Am I clear? So next, so here we'll move on the solution. How we can do best. Sir, when I talk about the solution, see here, my dear students, I would like to tell you one important thing, Amma. When I talk about the important thing here, sir, first of all, we should study as per the code. Okay, what is as per the code? So what is as per the code we will discuss, sir. Now, as per the code, we will discuss everything now. One second, student. One second. Okay. Now see, students, if I talk here, if there is a reinforcement here, if I have a reinforcement here, okay, sir, this is as per the IS4 code I am telling you. As per the IS4 code I am telling you. Okay. Sir, this is the actual code says. What is the code says is, if this is considered as effective depth D and this is the width of the section B, sir, these important things you should be aware of. Sir, what is the stress at concrete? It is 0.0035 and the value at this up to here, where parabola becomes a straight line, the value here is 0.002. And what is the value? What is the maximum strain in steel? This is the maximum strain in concrete, and the maximum strain in steel is 0.87 Fy ES. What is ES? Young's modulus of steel plus 0.002. And I want everyone to go through this slide. Very important, Amma. This is 446 FCK. You can write approximately equal to 0.45 FCK. You can write approximately equal to 0.4 FCK. And remember, we have the compression force acting at somewhere which is 0.42 XU. Okay. Okay. This compression force will act at a distance 0.16 XU. You can write 0.42 XU. And remember the tension force here. Compression force is given by the formula 0.36 FCK B into XU. And the tension force is given by the formula 0.87 Fy AST. And the lever arm, whatever the distance from this, the lever arm is given as D minus 0.42 XU. D minus 0.42 XU. So this is what I would like to tell you. So what is moment and all? Are you clear, Ma? Is this clear for everyone? Is this clear, sir? Any doubts in this, my dear students? Any doubts? Okay. Now see, students, now actually the partial safety factor of concrete is given as 1. Factor of concrete is given as how much? 1. So the first thing it will change here is, sir, if you see the graph here, the graph here, it is showing the value of 0.67 FCK. So when I talk about the design strength, it is 0.67 FCK divided by 1. So the value will be equal to 0.67 FCK. Am I clear, sir? Now we will draw the diagram, sir. Now see, students, if I take this as a section, okay. Now from similar triangle concept, like we have one more thing, we'll calculate those values also. Okay. Now if we talk about the, here we have, it is parabola, right? So it is parabola, right? So what is the stress here we got? we got it as 0.67 FCK. It is not 0.45 FCK, it is 0.67 FCK. But actually it is parabola. Actually it is what? Parabola. But now what we have to see, sir? Now what we have to see, my dear students? In the diagram. So you can see here in the diagram clearly. In the diagram it is clearly what, sir? In the diagram it is clearly shown that it is linear. Actually it is parabola. Are you following, my dear students? Are you following, sir? Can you please reply quickly? It is 0.67. How 0.67 came? Because the factor of safety of concrete has taken as 1. Now, this value, the strain here is 0.002. The strain here is 0.0035. Now, if I, in the previous class also I have told you, what is x dash and x double dash. So, remember here, x dash upon, okay, you can write 0.002 is equal to, what is that, this one? This is called XU. That is depth of neutral axis, XU upon 0.0035. So, my dear students, what will be this value, Amma? What will be this distance now? This will be equal to 4 by 7 XU. This will be equal to 4 by 7 XU. And this portion will be equal to 3 by 7 XU. Am I clear, sir? Is it clear, my dear students? Is it clear? The area of the stress diagram, if you consider this area, the area of this diagram will be your compression force. So, compression force will be calculated as 0.67 FCK. Now, what is the area of rectangle? Area of rectangle is B into 3 by 7 XU. B into 3 by 7 XU. So, this is the area of rectangle plus, what is the area of triangle? 0.67 FCK. This is the stress and the area is half into B into 4 by 7 XU. I am really waiting for your answer. Can you please quickly answer me? Students, can you please quickly answer me? What is the answer? Students, you have to answer me quickly. Students, I am waiting for your answer. Quickly answer me. What is the answer, sir? Okay. It is equal to 0.4785 FCK B into XU. Am I correct? Everyone got the same answer, Amma? 0.4785 into FCK into BXU. Have you got the same answer, my dear students? The answer here is 0.4785 FCK B into XU. Is it clear, my dear students? Can you quickly answer me? Okay. So, this is the compression force. Now, we also have to do the tension force because he is asking the depth of neutral axis. So, what is the tension force we have to calculate? There are 3 bars of Fe 415 grade, each of 16 mm. So, my dear students, when I talk here, we'll see here. Based on the formula, compression force is equal to tension force. What is the compression force here we have? Compression force is equal to 0.487 FCK B into XU is equal to 0.87 Fy AST. Okay. Now, what is XU, sir? XU is equal to, are you following, my dear students? Are you following? Prashant, ignited mind and everyone. So, what is 0.87? What is Fy, sir? What is the value of Fy, my dear students? What is the value of Fy? Fy is 415 into 3 bars of 16 mm dia. 3 into pi by 4 into 16 square. So divided by 0.4785 into FCK is how much, my dear students? Can anyone tell me what is the FCK value? What is the grade of concrete? M20. What is the grade of concrete, sir? M20. So M20 into width of the section. What is the width of the section again? Anyone, can you answer me? What is the width of the section? Width of the section is 300 mm. Width of the section is 300 mm. So can you tell me the answer, my dear students, quickly? My dear students, please tell me quickly what is the answer, sir. I'm waiting for your answer. I'll wait for a couple of seconds to answer. Okay, please tell me quickly. Can anyone tell me answer quickly, my dear students? Anyone in the class, can you tell me what is the answer, XU? Very good, Prashant, very good. I really like. Very good. You are fast and also very interesting. 75.81 mm. Very good, Prashant. So the depth of the neutral axis is 75.81 mm. The depth of the neutral axis is how much, my dear students? The depth of the neutral axis is 75.81 mm. Is it clear, my dear students? Is this clear, Amma? Okay. Now, when I talk about the depth of the neutral axis as 75.81, he is asking the second question also. So, what is the first answer you can say? So, he has asked, now please see the question, Amma. He has asked the depth of the neutral axis from the compression fiber, 100 mm, 87 mm, 81. So, you can write the answer as 76 mm. You can write the answer as 76 mm. But he is asking what is the difference or the depth of the neutral axis obtained from the code IS 456. How much is differing from the depth, whatever the neutral axis you have found out. So you can assume the neutral axis is how much, Amma? 76 mm. The depth of the neutral axis is 76 mm. Now can you solve it? Sorry. Now, can you solve it, my dear students? Can you solve it, sir? So, that is simple, Amma. According to the IS 456 code, compression force is equal to tension force. So, compression force is how much, Amma? 0.36. This is from according to the code IS 456. This is according to the code IS 456. So, you can write here 0.36 FCK B into XU is equal to 0.87 Fy AST. This is the formula. Or you can write depth of the neutral axis is equal to 0.87 Fy AST upon 0.36 FCKB. Okay, now what is the grade of steel, Amma? Grade of steel is 415. Area of steel is 3 bars of 16 mm, 3 by 4 into 16 square. And we have 0.36. Grade of concrete is 20 and the width of the section is 300. Sir, if you have any doubts, this is Fy. This is Fy. This is the AST. Sorry, my dear students, this is Fy. And this is the grade of concrete. This is the grade of concrete, or you can write FCK, and this is the width. Now quickly answer me, my dear students, quickly. What is the answer? What is the answer, my dear students? Can you tell me the answer quickly, my dear students? I am waiting for your answer. Sir, we are very good, Amma, very good, Prashant, very good. It is around 100.77, or you can say roughly 101 mm. So, he is asking not this value, he is not asking this value, he is asking the difference. The difference will be equal to, 101 minus 76, that will be equal to 25 mm. That will be equal to how much, sir? That will be equal to 25 mm. Ramakrishna, 101, 100.77. 100.77. Very good, Ramakrishna. Very good. Okay. Sir, see, simple calculation, Amma. 300, 415, 1.3. 1.3, 2.5. This will be 8. So, you can write how we will do also. 2.5, 8. 8 into 300 is 1.4. 1.4 divided by 8. 1 second, my dear students. 1.4 divided by 8. Because this is 8, it will come. Into 256. Into 3.14. Into 0.75. This will be your answer. 256 into 1.4 is roughly 350. 350 into 3 is 1050. 1050 into 75, it will be around 800. 800 divided by 8. So the answer will be roughly 100. Agree, Ramakrishna? Agree. Ramakrishna, I did not understand why you have kept question mark. The answer is 100.77 is absolutely correct. Okay. Check the values also. I have told the solution also how we can do. Sir, 0.36, 0.87, 2.5 and 2.5 28 times. And I have done this calculation. If you have any doubt, you can go through this, Ramakrishna. Okay. Is it clear, my dear students? So the difference in the difference between these before and now is 25 mm. So remember, my dear students, when they are asking to calculate the compression force will be calculated as the area of the stress diagram. And the stresses values at the extreme fiber will depend upon the partial safety factor. When the partial safety factor changes, okay, thank you, Ramakrishna. When the partial safety factor changes, you should understand that when the partial safety factor changes, you should understand that the stress parameters also changes, the lever arm changes, and if also there can be a change. So also there can be a change in the moment. So these things please keep in mind, my dear students. So quickly go through this question, my dear students. Quickly go through this. Please wait, my dear students. I'll be back in a minute. Students, am I audible? Can you quickly respond? Sir, see, the question here is the cross section of the, see, remember, my dear students, the cross section of the reinforced concrete beam having an effective depth of 500 mm is shown in the figure. One second. See, 1 second. The cross section of the reinforced concrete beam has an effective depth of 500 mm. The grades of concrete and steel are M35 and Fe 550 grade of steel. The grades of concrete are M35 and Fe 550 grade of steel. The area of tension reinforcement is 400 mm square. The area of tension reinforcement is 400 mm square. It is given that a corresponding 0.2 percentile of proof stress, the material safety factor is 1.15, which you know already. Which you know already. Okay, my dear students, which you know already. So, is the question clear? Is the question clear? He is asking what is the limiting depth of neutral axis measured from the compression fiber. He is asking what is the limiting depth of neutral axis measured from the compression fiber. Please look at to that question, my dear students. Please look into that question, student. Now see students, before moving to this question, I would like to give you some concept related to T-beam. So before moving to this question, I would like to give you some concept before what is T-beam. Sir, actually T-beams and L-beams are related to, means you can say that T-beams and L-beams are related to flange beams, okay? T-beams and L-beams are related to flange beams. And remember my dear student, if I take this as a T-beam, okay, when you said that this is, see, when you say depth of neutral axis, what is XU? XU is when you say depth of neutral axis is less than or equal to depth of the flange. When depth of neutral axis is less than depth of the flange. Sir, my dear students, this is called the depth of the flange. So he is telling that depth of neutral axis is less than or equal to depth of the flange. When depth of the neutral axis is less than the depth of the flange, what I would like to add here is you have to understand that neutral axis lies in flange. You have to understand that neutral axis lies in flange. When I say that neutral axis lies in flange, my dear students, when I say that neutral axis lies in the flange, then T-beam behaves as a rectangular beam. Then what will happen? T-beam behaves as a rectangular beam. T-beam behaves as a rectangular beam. T-beam behaves as a rectangular. Clear, my dear students? When you say that T-beam behaves as a rectangular beam, you are going to say that T-beam is going to behave as a rectangular beam. Okay. So what do you mean by here? What I would like to tell you here is the case 1, when the depth of the neutral axis lies, or when the depth of the neutral axis is less than the depth of the flange, then the neutral axis lies in the flange, then T-beam behaves as a rectangular beam. That means whatever the formulas which are related to T-beam, which are related to rectangular beam will be considered here. So the case 1 you can write it here, my dear student. Please write down this, my dear students. Please write down. I'll give you 1 minute of time. Please write down this. Students, can you hear me? Can you hear me? Students, can you hear me? Okay. Ramakrishna, why it is less than or equal to? Why is it not just less than? Okay, Ramakrishna, that's a good question, Amma. What I would like to tell you is, this df is known as depth of flange, Amma. This df is known as depth of the flange. When the depth of neutral axis is less than means, what is less than indicates that when the neutral axis is less than, when the depth of the neutral axis is less than depth of the flange means it will be inside the flange. The neutral axis lies inside the flange. Now, if suppose if it is equal to the depth of the flange, the neutral axis will somewhere lie here. Means it will lie at the edge of the, then also it behaves as a rectangular beam. Whether it lies on the interface or inside, both will act as what, my dear students? In both the cases, it acts as a rectangular beam. So, my dear students, that is a good question, Ramakrishna. So, no need to worry that when XU is less than or equal to, you should understand that the beam behaves as a rectangular beam. The beam behaves as a rectangular beam. So here, my dear students, what is the important thing I would like to tell you here is the next case. Ramakrishna, I think you are following. Okay. Now, the second case is, what is the second case we have is the case 2. Now, Ramakrishna, as you told, XU is less than or equal to DF, the neutral axis is going to lie in the flange. Now, suppose if XU is greater than DF, now when XU is greater than DF, then neutral axis lies in web. Neutral axis lies in web. Now, my dear students, if you ask me what is flange and what is web, if you ask me what is the flange and what is the web, as a civil engineering, you should be aware of these things. Or still, this is considered you as web. Sorry, this portion, whatever I have drawn now, that will be considered as flange. And this portion, whatever we have here, this red color portion is known as web. This is known as web and this is known as flange. Am I clear, my dear students? Am I clear? So this portion is considered as flange and this portion is considered as web. Now, he is telling the depth of neutral axis is greater than depth of the flange. So neutral axis lies somewhere here. Neutral axis lies somewhere here. But remember, my dear students, I want to tell you one important thing also. Here there will be again two cases. You know that rectangular portion is how much, Amma? This is 3 by 7 XU and this portion is 4 by 7 XU. Okay, my dear students, this portion is 3 by 7 XU and this portion is 3 by 7 XU. Suppose here one thing, we call this as depth of the flange. There is another case that here, suppose, my dear students, when 3 by 7 XU is greater than DF, when 3 by 7 XU greater than DF, you can take compression force as, you can take compression force is equal to compression force of flange plus compression force of the web. It will be considered as compression force of the flange plus compression force of the web. Sir, remember, my dear students, Ramakrishna, you can again ask me this doubt. You please listen. When 3 by 7 XU is greater than DF, this 3 by 7 XU is greater than DF indicates that the stress is uniform. Indicates that the stress is uniform. So, up to somewhere, along the depth of the flange, the stress is uniform. I would like to say that the depth of the flange is uniform along the depth. So, along the depth of the flange, the stress is uniform. So, whenever the depth along the depth of the flange, when the stress is uniform, I would like to, this will be idealized. This beam can be idealized in this way. This beam can be idealized in this way. Sir, for your understanding, I am showing you, Amma. This beam can be idealized in this way. So this portion, we can take it as a flange. So flange, so this portion is breadth of the flange. So what will be this area, red color area? So we take this as breadth of the web. So what will be if the area of the flange means breadth of the flange minus breadth of the web into depth of flange. Because area of rectangle, what is the area of rectangle, Amma? Length into breadth. Sir, breadth is nothing but the, sir, Ramakrishna, let me complete this and I will get back to you. So it is BF minus BW into DF, that is depth of the flange. So here what I would like to tell you is the breadth of the flange minus breadth of the web is multiplied by depth of the flange will give you the area of the flange. Okay. Now what will be the area of the web? What will be the area of the web? The area of the web is nothing but the, suppose if we have a steel bars here, this you can consider this simply, Amma. This you can simply consider this as what? This as a rectangular portion. So how do you design for rectangular portion? The same formulas you can adopt for web also. What is the point I would like to tell you is, for web you can adopt the formulas as rectangular, and the stress here is what, sir? The stress here is 0.45 FCK. So in this case, my dear students, in this case I would like to tell you the compression force, one is due to flange 0.45 FCK. This is the stress into breadth of the flange minus breadth of the web into DF plus, this is the compression force due to what, sir? This is the compression force due to flange plus, what is this is the compression force due to flange, and the other one we have is what, sir? The other one is the compression force due to what, sir? The other one is the compression force due to what? Due to web, and that web is given by the formula 0.36 FCK BXU. Because this is the same formula, here B will be taken as BW. Here B will be taken as BW. This is the compression force of web. So when I talk, this is the compression force formula. When I talk about the moment formula, moment will be taken as 0.45 FCK into breadth of the flange minus breadth of the web into DF into D minus DF upon 2 into D minus DF upon 2. So here when I take a rectangle, means T-beam, okay, my dear students, if you have these steel bars here, what will be the lever arm distance? The total distance will be D, Amma, and this distance will be DF by 2. So this distance will be DF by 2. So what will be this distance is nothing but D minus DF upon 2. So that's what I have written over there. So this is the moment due to what's our flange, and the moment due to web is 0.36 FCK BW into XU multiplied by D minus 0.42 XU. So this is the case, my dear students. You should understand that when 3/7 XU is greater than DF, and when XU is greater than DF, this is XU greater than DF, and another internal case is 3/7 XU greater than DF. You can use these formulas and solve the problem. Now, there can be another question. Please write down this question. Sorry, please write down or understand this concept. I'll give you 30 seconds of time. Okay, my dear students, there is another case which I would like to tell you. There is another case, Amma. What is the other case we have is, sir, until now we have discussed the last case. And remember, sir, another important case I would like to tell you, the depth of the neutral axis will be calculated based on every case. Sir, XU value changes based on each case. You cannot use the case one. If XU is less than or equal to DF, the neutral axis lies in flange. You cannot use that XU in the case 2, or you cannot use that XU in this case. Every time when the case changes, you have to find the respective depth of neutral axis. Please keep this in mind, my dear students. The depth of neutral axis which is considered at the first is not considered for the second one. The depth of neutral axis should be calculated based on the respective cases. Am I clear, my dear students? Any doubts in this? Any doubts in this, Amma? Any doubts? So here I would like to tell you one important thing, sir. Here what I would like to tell you here is the moment formula. So here when the third case here is 3 by 7 XU less than DF. What is the 3 by 7 XU less than DF is, if this is a rectangular section, Amma, if you see the stress strain diagram, sorry my dear students, we are not talking about rectangular, we are talking about what, sir? We are talking about the T-beam. Okay. So we are talking about the T-beam. So here what I would like to tell you here is, now my dear students, please respond quickly. So what I would like to tell you is, if this is a T-beam, Mama, if this is a T-beam, what I would like to ask you here is, in case of a T-beam, if the stress distribution diagram is, somewhere here, is telling up to here, okay. From here to here, 1 second, sorry students. Okay. 1 second students. We'll draw it again. Now see students, if we consider this as a T-beam, Mama, if we consider this as a T-beam, XE is greater than DF, that means neutral axis lies somewhere here, okay. But how is the stress block diagram? I want to show you. The stress block diagram will be like this. What does he say is, the stress is not uniform. Here this distance is what, sir? 4 by 7 XU. And this distance is 3 by 7 XU. From the diagram, 3 by 7 XU is less than DF. This indicates that the stress is not uniform. This indicates that the stress is not uniform. This indicates that the stress is not uniform throughout the depth. This indicates the stress is not uniform throughout the depth. Am I clear, my dear students? This indicates that the stress is not uniform throughout the depth. So here I would like to tell you, as the stress is not uniform throughout the depth, the code has come up with a factor. The code has come up with a factor that YF is equal to, please listen my dear students, YF is equal to 0.15 XU plus 0.65 DF. Sir, as the stress is not uniform throughout the section, they have come up with a factor YF from the code IS 456. And remember, in case 2 formulas, sir, in the case 2 formulas, wherever you find DF, Amma, replace the DF with YF. So all the case 2, please remember this students, the case 2 formula, wherever you find DF, replace the DF with YF. Replace that DF with what, sir? YF. So here you should understand that wherever you find depth of the flange, that should be replaced by YF. Is this clear for everyone, my dear students? Is the concept clear? Okay. Now let us go to the problem. So by using this concept, Amma, I would like to summarize on the T-beam and L-beams. T-beams and L-beams are called as flange beams. They are usually used in your in civil engineering labs like fluid mechanics labs or hydraulics labs, where large spans or bus shelters, you come across these T beams and L beams or parkings and all. Sir, in T beams, when the neutral axis is lying in the flange or when XU is less than DF, you design that beam as a rectangular beam. When XU is greater than the depth of the flange, you design that beam as what you will design? You will design that beam separating it a flange separately and the web separately. This is not for actual design, for finding the values. So we have done that. But still there is one case when 3/7 XU is greater than DF, it says that the stress is uniform throughout the section. When 3/7 XU is less than DF, wherever you find DF, DF will be replaced by YF. DF will be replaced by YF. Any doubt, my dear students? Is it clear? Now, my dear students, quickly respond. Are you comfortable in understanding the complete concept of T-beams? Is it clear, sir? So, very good. Just quickly respond in the chat box, Amma. Okay. Now, read the question, my dear student. The question here is, I just want to read the question carefully. Sir, see, the question here is, the cross section of the reinforced concrete beam has an effective depth of 500 mm and is asking the limiting depth. He is asking what is the limiting depth, but he has given the yield strain of steel. He has given the strain of steel. Am I correct or wrong? So he has given the yield strain of steel. So he is asking what is the limiting depth of neutral axis. So if you see the strain diagram, if you see the strain diagram, it will be 0.0035. As he is asking that see, if I assume this as XU max, because the maximum depth of maximum strain is 0.035, and this up to here we call it as effective depth D, and we take this value as D minus XU max. Okay, D minus XU max, and this value is given as how much, my dear students? This value is given as 0.0044. This value is given as how much, sir? 0.0044. Can anyone tell me? Sorry, my dear students, sorry. Okay. 1 second. So here, again I am drawing the diagram. The strain diagram looks like this. It is 0.0035 here, the strain in the compression side, and the strain in the tension side is 0.0044. And this value will be how much, Amma? This value will be equal to XU max, and this will be equal to D minus XU max. This will be equal to D minus XU max. This will be equal to how much, sir? D minus XU max. When they ask you what is this, Amma, can you tell me what is these values? So here, if you do from interpolation, XU max upon 0.0035. Sorry, from similar triangle concept, XU max 0 divided by 0.0035 is equal to D minus XU max divided by 0.0044. Is it clear, my dear students? Is this clear, Amma? So when I talk here, we say that D minus XU max divided by XU max is equal to 0.0035 divided by 0.0044. So here, when I talk here, so D by XU max minus 1 is equal to 0.0035 upon 0.0044. So this will be equal to D by XU max is equal to 0.0079 upon 0.0044. That is 35 plus 44 is 79. So what will be the XU max by D value, Amma? If you reciprocal it, XU max by D is equal, or XU max is equal to, what is the value? What is the value, sir? 44 XU max by D is 44 divided by 79. And what is the D value, sir? What is the D value, my dear students? Can anyone tell me what is the D value? D value is 500. Now quickly answer me, what is the answer? Sir, here small thing, the small correction, amma. It is not 44 by 79. Okay, 1 second, my dear students. Small correction. This is correct, right? Okay, 1 second, sorry. Small correction here. My dear students, this is how much, sir? This is 44 and 70. So this will be actually 79 divided by 35, right? So this will be also same. This will be also, 1 second, students. So this will be 79 into 35. Now please solve this. What is that? Sir, Prashant, I have done here, you might have taken 44, amma. It is not actually 44, it is 35. Because when we add this, it will be what, sir? 79, right? D minus XU max is 0.004 plus 0.007 divided by 0.004 or 0.0035. Check it once, students. Sir, here also we have done a mistake here. Please see, students, a small correction. 1 second, I'll do that correction here. Actually, what is the correction we will done? See here, actually one thing we have done here, sir. The similar triangle concept, we have done something. Okay. Now please, Prashant, see. Okay. What is the value? Sorry for this. Pardon me. Students, what I would like to tell you is XU max divided by 0.0035 is equal to D minus XU max upon 0.0044. Okay. This distance upon this distance and this distance upon this distance, right? So when I do this, you have written that D upon XU max by XU max is equal to what, sir? 0.0044 divided by 0.0035, right? This can be written as D upon XU max is minus 1 is equal to 0.0079 upon 0. So here we can erase that minus 1. I am taking that side. Okay. So it will be equal to this will be equal to 0.0035. So XU max is equal to XU max by D is equal to 35 by 79 into DM. 35 by 79 into D. So D is how much, my dear students? What is the value of D? What is the value of D, my dear students? What is the value of D? D is 500. Prashant, have you checked the answer now? Prashant Jalagam. Sir, here we have cased instead of 0.0035 upon 0.004, I have just made a correction because I have just by mistake I have written that. Okay. So please correct me and correct the answer. What is the answer you will get? Prashant, what is the answer? So here, very good, Kiran, very good. The answer is 221.52 mm. The answer is 221.52 mm. Is this clear, sir? Very good, very good. Sir, small things will be happening sometimes when we are in live. Actually, I have just written instead of 1 by upon, the values are interchanged. Okay, so that's not at all an issue. Okay, we'll move on to the next question. Sir, I want everyone to read this question, okay, before we start the problem. Okay. Okay, my dear students. The question here is a square pad type footing of size how much, Amma? 3.5 meter in size. A square pad type footing 3.5 meter in size is support to a square column of 500 mm size. The effective depth of the footing is 560 mm. The effective depth of the footing is 560 mm. The safe bearing pressure is 122.4 kilopascal. Okay. For one-way shear, the design shear force and the nominal shear stress is. Okay. For one-way shear. So, first of all, my dear students, I would like to tell you one important thing, Amma. The critical section for one-way shear will act at a distance d. This you should understand, Amma. The critical section will be acting at a distance d from the face of the column. From where, sir? From face of the column for one-way shear. From face of the column. So, critical section will act at a distance of d from the face of the column. So, if I told you here, my dear students, if this is a square footing and we have a column, okay, what is the column size, sir? The square footing is, the square footing is of size 3500 mm because it is 3.5 meter, so it will be 3.5 mm. And here, when I talk here, this is how much mm? This will be equal to 400 mm. And I told you clearly, when I told you clearly here, the critical section is acting at a distance d. Okay. So, we should know that this is the portion. So, remember, critical section acts at what distance, sir? For one-way shear, it acts at a distance d from the face of the column. So, what is this distance? So, you can write. Now, see, my dear students, I will go through this problem very clearly for you. Now, see, we have a diagram here. Sir, see, this is the column we have. We can say column as A and the length of the column is L, and we have a section here and it is acting at a distance d. So, this area we have to find out. So, if anyone asks you, my dear students, in this case, the design shear force is equal to pressure into area. So, what is the area you can write is, if I take at the center, it will be equal to L by 2. Okay. And this distance you have to remove to get this distance, Amma. To get this distance, whatever the blue color which I am showing, to get the distance, L by 2 minus A by 2 minus D will give you the design shear force. Will give you what, sir? Give you the design shear force. Nageshwar, oh, thank you, Nag. Okay, here we have Q naught is 122.4 kilopascal or kilonewton per meter square. It is in kilonewton per meter square, Amma. Okay, and we have length is 3.5 divided by 2 minus, what is the size of the column we have is, size of the column is 0.4 divided by 2 minus effective depth. Effective depth is given as 0.56 mm. 560 mm, you can take it as 0.56. Sir, this is pressure into area. We have taken only this length. Then where is the area? area is nothing but this entire face, that is B. So, but it is a square column, so length will be equal to breadth. So, the value here is 3.5. So, what is this value? Can anyone tell me quickly? Can anyone tell me quickly, Amma? What is this value? You will get a value of around 424.16 kilonewton. Anyone got this value, sir? Kiran or Prashant? Have you got this value, Kiran or Prashant? 424.16 kilonewton. Okay. So now he has asked not only the design shear force, he is asking the nominal shear stress also. He is asking nominal shear stress also. So here nominal shear stress, which I told you already, nominal shear stress is given by the formula, my dear students. Nominal shear stress is given by the formula. Can anyone tell me how the nominal shear stress is given? The nominal shear stress is given as nothing but the design shear force upon, you will take the overall width because B into depth. So VDS is 424.16 kilonewton. It is kilonewton. To convert into Newton, you will take 10 power 3. And B is how much, sir? 3500 mm and depth is 560 mm. Okay. So what is the value you will get? Please tell me quickly. Can anyone tell me quickly, sir? What is the value? What is the value, sir? Anyone quickly? The nominal shear stress will be 0.216 Newton per mm square, or they can call it this value as MPa. Okay, we'll check the answer, Amma. We'll check the answer. So the answer here is 425 kilonewton and 0.216. You can write it as 0.22 Newton per mm square. Is this clear, sir? Is this clear? So the important point what I would like to add here is, my dear students, in case of one-way shear, the critical section will act at a distance d from the face of the column. In case, my dear students, can you please respond? The critical section will act at a distance d from the face of the column. Am I clear, sir? Okay. Now please see for the same question, he is asking for a two-way shear, the nominal shear stress and the design shear forces. Remember, my dear students, when I talk about two-way shear, it acts at a distance d by 2 on both the faces. Two-way shear means it acts on both the faces. So it will be d by 2, d by 2, d by 2. Okay, so it will be d by 2. Will be d by 2, d by 2. So here, this is how it acts. This is how the two-way shear acts. So when I talk about the shaded area, design shear force is equal to pressure, that is safe bearing capacity or soil pressure or anything, multiply the area of the shaded portion. Sir, here it is length. If I take the size of the column as L, so total area is L into B minus A plus D into B plus D. Sir, this is the generalized formula. You can remember. It is something like hollow section, Amma. So you can write the total area, rectangle minus this portion area, because if I take this as A, this will be A plus D by 2 plus D by 2, A plus D. And this, if I take it as, sir, column size, if I take it as A and B, Amma, A plus D by 2 plus D by 2 is A plus D. And here we take it as B, B plus D by 2 plus D plus D is B plus D. Is it clear, my dear students? Can you quickly respond? So here the design shear force is given by the formula 122.4. L into B is 3.5 into 3.5 minus, what is A? Sir, here I have taken in meters, amma. A is 0.4 meter, the size of the column, plus the effective depth is 0.56. It is a square column, so it will be same 0.4 plus 0.56. So can anyone tell me what is the answer, sir? Can anyone tell me what is the answer? Can anyone tell me what is the answer? Anyone, my dear students, can you quickly answer me? What is the answer? If you solve this, you will get a value of 1386.5 kilonewton. 1386.5 kilonewton. Okay? Okay. Now, my dear students, so the design shear force is how much, sir? 1386.5 kilonewton. And you can write approximately 139. Now the nominal shear stress. Sir, this is very important, Amma. The nominal shear stress, when I talk about the nominal shear stress, how it's going to act. The nominal shear stress is going to act, if this is a rectangular section, my dear students, if this is a column and we have the section here like this, so the nominal shear stress will act at this portion. This will be, because two-way shear will act on this entire circumference. If you talk about one-way shear, it acts on the face of this side, but it acts on all the faces. So nominal shear stress is given by the formula design shear force into, what is this perimeter, if you take 2 into L plus B, 2 into A plus D, okay, this is this length plus, sir, circumference I am taking, amma, B plus D, okay, into the effective depth D. Sir, most people will forget this, amma. When you, in case, most of the students will forget this, my dear students. In case of two-way shear, my dear students, am I audible? In case of two-way shear, you have to take the circumference of this, okay, and the effective depth D. Okay, you can say that will be equal to 1386.5 into 10 power 3. Because it is a square, amma. Because it is a square, you can take it as 4 into S, that is 4 into 2 into this, 4 into 4S, because of a square. 4S is how much, sir? This is 400 and this is 500. So 4 into 960 into effective depth is 560. Now quickly tell me what is the answer. Now, my dear students, can you quickly answer me what is the answer? Students, are you following? Can you please quickly answer me? This is 560. Can you tell me quickly, sir? Anyone? What is the answer you got? Very good, Kiran. Very good. So the answer is around 0.645 MPa. Okay. Now see, sir. So the answer you can write here is 1390 and 0.64 MPa. 1390 and 0.64 MPa. Is it clear, my dear students? Is this clear for everyone? Any doubts, Amma? Any doubts in this problem? Okay. Oh, sorry. Now see this question carefully. Read this question carefully, Amma. A rectangular beam 250 into 600 mm is pre-stressed by 414 mm dia, 414 mm high tensile wires. What, sir? Is pre-stressed by 414 mm high tensile wires located at 200 mm, from the suffix of the beam. If the effective stress in steel wires is 700 MPa, what is the maximum bending moment due to dead load that can be applied so that there will be no tension? Is it clear, my dear students? Again, I repeat this. A rectangular beam 250 into 600 mm is pre-stressed by 414 mm bars. Okay, now my dear students, I'll give you some insight of the pre-stressed concrete beam. Sir, see, when do you go with pre-stressed? When you see the metro stations in all the Bangalore or Hyderabad, wherever you see, most of the metro stations are related to the pre-stressed concrete. Why pre-stressed concrete is because how much section you require, that much only you will be provided with pre-stressed. And pre-stressed concrete offers more resistance to fatigue loading. What exactly is fatigue loading is the repeated loading. So pre-stressed concrete offers more resistance to fatigue loading or impact loading, load falling from a height or vibrational loading. So that is the reason people you are following with the pre-stressed concrete, and the construction is very fast, and we have the help of the mechanical people for erection and all. So the deflections will be very less in pre-stressed. But my dear students, in pre-stressed concrete, we have two methods. One is pre-tensioning method and another one is post-tensioning. What exactly do you mean by pre-tensioning? My dear students, when the steel wires are tensioned before casting of concrete, we call that as pre-tension. When the wires are tensioned after casting of, means I'll tell you, in post-tension, there will be some ducts and you will be introducing into the ducts the steel wires, and then you will be doing the tensioning. So after concreting, if you do the tensioning, then it is called post-tensioning, and before concreting, if you do the tensioning, that is called pre-tensioning. Bond is the main factor for transfer of stresses in pre-tensioning, and end bearing is the main factor for transfer of stresses in post-tensioning. Remember, my dear students, in post-tensioning, the space between if you see the post-tensioning, this we call it as duct summa. Here we will have tendons, a group of wires or tendon. The space between the tendon and the duct is grouted. And remember, sir, you know the railway sleepers, bulk or mass production of railway sleepers are done using the principles of pre-tensioning. This is post-tensioning, not pre. Railway sleepers are done in the post. Railway sleepers are produced mainly on the which operation, my dear students? They are done mainly on the pre-tensioning operations. And for long span bridges, they go with the post-tensioning operations. For long span bridges, they go with what, my dear students? They go with the post-tensioning members. And remember, my dear students, when we talk about pre-tensioning and post-tensioning also, we use usually in pre-stressed concrete the high grade concrete and steel. Why? Because if you use mild steel, if you use mild steel 250, the working stress of the mild steel is 140 only. Remaining 110 is lost due to elastic shortening of concrete or creep of concrete or shrinkage. As the losses are also taken into account, and the loads are heavy, we are taking the high strength concrete and steel, and it is sorry, my dear students, it is mandatory in case of pre-stressed concrete to go with high strength concrete and high strength steel. Is it clear, my dear students? Am I clear, sir? Am I clear? Now, my dear students, see here the section is how much, amma? The section is B is equal to 250 mm and D is equal to 600 mm. So here the first thing what I would like to ask you is the stress in steel wires. The stress in the steel wires is how much, sir? The stress in the steel wires is 700 MPa. The stress in the steel wires is how much, sir? 700 MPa. Okay. Now, what will be the pre-stressing force, amma? What is pre-stressing force? What will be the pre-stressing force? Anyone in the class? Anyone? Can you please let me know, amma? What will be the pre-stressing force? What will be the pre-stressing force? Can you please respond quickly, my dear students? Pre-stressing force is equal to pre-stress multiplied by the area of steel. So the pre-stress in steel is, the pre-stress is how much, sir? The pre-stress in the effective stress in steel wires is 700 MPa. And how many bars are there? There are 4 bars of, there are 4 bars of, there are 4 bars 1 second, students. There are 4 bars of 14 mm square. So can anyone tell me what is this answer? What will be the total load, Amma? So it will be 700 multiplied by around 200 into 600. So this will be around, if you calculate this, you will get a value of 431.2 kilonewton. You will get a value of 431.2 kilonewton. And one more important thing, most of the people, sir, they have told that there is no tension developed at the soffit of the beam. There is no tension. Soffit means what, sir? Soffit of the beams are what? Soffit of the beams are nothing but what? Bottom of the beam. Soffit are nothing but the bottom of the beam. So here, my dear students, when I see the pre-stressing force, is telling there is a neutral axis and we know the stress at bottom. The stress at bottom. Sir, see here, this is very important, Amma. The stress at bottom is given by the formula P by A plus PE by Z upon minus MD plus ML upon Z. Sir, when they tell you that there is no tension, this value will be equal to 0. When they tell you that there is no tension, this value will be equal to 0. So what is that? Sir, how this formula came? If anyone asks you, you know the equation M by IE is equal to F by Y is equal to E by R. So here what is M, Amma? M is given as M into Y by I. If I take these two equations, M into Y by I is equal to F, where bending stress Y by I can also be written as M is equal to M upon I by Y. What is I by Y, sir? You can write it as Z. So bending stress can be written as moment upon section modulus. So bending stress can be written as what, my dear students? Bending stress can be written as moment upon section modulus. That's what. Moment is nothing but you take, what is the moment, sir? The moment, if you have a pretensioning wire, if we consider this as a tendon, Amma, we have the pre-stressing force. Here you have the pre-stressing force, and due to this wire, there will be a moment, that is, it is acting at an eccentricity, E. So moment will be equal to P into E. So what is the pre-stressing force? What is P means? My dear students, P is nothing but the pre-stressing force. Hello, my dear students, can you quickly respond, Amma? Okay, I hope you are following. Any doubts, my dear students? You can simply post in the chat box. Okay, now when you tell about pre-stressing force, we have pre-stressing force is equal to 431.2 into 10 power 3 upon the section. What is the section we have? The section is 250 into 600, Amma. So the section is 250 into 600 plus. Sir, whenever you tell there is no tension, equate the stress at bottom to 0. Please write down this point again, my dear students. When they tell you there is no tension, the stress at bottom will be considered as 0. The stress at the bottom will be considered as 0. Any doubts, my dear students? Any doubts? So, what is the eccentricity? Sir, one more thing, my dear students. See, the wires are located at a distance of 200 mm from the suffix of the beam. The wires are located. See, the overall depth is how much, Amma? The overall depth is 600. Okay. So, if I consider the half of it, it is at what, sir? It will be at 300. So, half. Now, it is located at bottom. From bottom, it is 200. So, what will be the eccentricity? Eccentricity can be written as overall depth minus 2 minus 200. So, eccentricity will be equal to 100, where overall depth is equal to 600 mm. Am I clear, my dear students? Is this clear? I want to repeat this again. The overall depth is 600. So, overall depth by 2 minus 200. So, eccentricity is 600 by 2 minus 100. So, that value, the eccentricity will be equal to 100 mm. That value, eccentricity E will be equal to 100 mm. Any doubts, my dear students? Any doubts? So, when I tell you hey, eccentricity is 100 mm, sir, Z, if you ask me what is the Z of a rectangular section, it is nothing but BD square by 6 amma, because Z is equal to I by Y. Z is equal to I by Y, where I is known as moment of inertia, Y is the distance from the neutral axis to the extreme fiber. For rectangular section, it is BD cube by 12 divided by D by 2. You will get BD square by 6, which you are more aware in the strength of materials concept. Okay. So here what I would like to tell you, my dear students, it is BD square by 6. So P is 431.2 into 10 power 3 upon depth is 250 into 600 square upon 6 into 100 is equal to MD plus ML upon Z. Okay, this is the equation. My dear students, again I will tell you the shortcut in the solving the problem, how I will solve this problem. Sir, so we have one is P by A plus PE by Z can be written as MD plus ML upon Z. My dear students, when I write this, please see here 431.2 into 10 power 3 upon area is 250 into 600 plus what is eccentricity, amma? What is the load here we have? Load is equal to 431.2 into 10 power 3. Eccentricity is how much, sir? Eccentricity is 100 mm divided by Z. Z is 250 into 600 square upon 6. 250 into 600 square upon 6. Is this clear, sir? Is this clear? Thank you, Satish Garu. Thank you, Satish. Okay, is equal to MD plus ML. What is MD plus ML is? We have moment due to dead load plus moment due to live load. So here we have Z is how much, sir? Z is given as 250 into 600 square upon 6. My dear students, whoever feels how to solve this equation easily, please see here. I will tell you very simply, amma. It is 250 into 600, right? This is 250 into 600. And if you cancel 600 by 6, 100 it will, 100 cancel. Again, it will be also 250 into 600. So both sides, if you cancel 250 into 600 into 250 into 600, there will be only 100 availability. So 250 into 600 and 600 by 6. Are you getting me? Again, I am telling you. This, take 250 by 600 common in all the cases. So if you take that here, it will be 100 value. And here also it will be 100. So entire 250 by 600 will be cancelled. So you can write MD plus ML is equal to 431.2 into 10 power 3 into, this is 1 plus 1. So into 2 into this denominator will be 100. Okay, if you see this, you will get 86.2 into 10 power 6, my dear students. If you see, you will get 862.4. 862.4 into 10 power 5 you will get. I have modified it to 86.2 into 86.2 into 10 power 6. So this value is taken as Newton mm, my dear students. This value is taken as how much, my dear students? This value is taken as 86.2 Newton mm. So the overall value is given as 86.2 kilonewton meter. The overall value is given as 86.2 kilonewton. Any doubts, my dear students? Any doubts? Students, you should be really excited. My dear students, IMS GATE Academy is coming with very good concept that the entire team is ready to boost you the concepts in a easiest and the shortest way. We are here to help you using the problems and the concepts. What best we can do for the GATE exam we are delivering. So don't try to attend the sessions regularly. Every day from 6 p.m. to 9 p.m. we are coming live, and we have a very good civil engineering team which is with myself, Sandeep Adari, and we have two more members in our team, that is Pratik Mishra and Ankit Dongrial. And Ankit is going to deliver the most important subject, geotech, and please wait for the class also, and I will be taking geomatics also. Remember, my dear students, when you are preparing for GATE, consistency. Remember, you know how Virat Kohli has been, why he is called as the master of cricket, because like when you say Sachin Tendulkar is the master of the cricket, now we are going to say Kohli is the master. Why? Because he is consistent in his innings, how he build up the innings. So that kind of planning and strategy is required in GATE also. Okay, and don't waste your time watching Qatar FIFA World Cup, and it is the important time for all the GATE aspirants to utilize this time for this active. Means you just try to revise your concept, give as much as you can. IMS GATE Academy is also coming with All India mock test series, and you can visit our website IMS GATE Academy and you can feel the AMTS work, like All India mock test, and you can have a look of it. Thank you. Students, next question. Next question. See students, a rectangular post-tension concrete beam of span 10 meter and 150 mm wide and 300 mm deep is pre-stressed by a cable of initial pre-stress is 1200 MPa. What is the initial pre-stress, my dear students? The initial pre-stress is 1200 MPa. The cable is parabolic with an eccentricity of 50 mm at midspan towards the tension zone, and coefficient of friction between ductile and cable is 0.3. Wobbling constant is 0.04. Percentage loss of pre-stress due to friction when the cable is tensioned from one end. So students, just give me a 1 minute, okay? I'll be back. Meanwhile, understand the question carefully.
Seconds. Correct. What's
These again and again I'm telling you, mark my word, my dear students. I want to tell you one very important thing. In RCC, when you are preparing for GATE, please cover the basics of LSM, and please cover the basics of shear, and please cover the basics of loss of pre-stress, and also the fundamental IS 456 specifications. Okay, my dear students, in this my 10 years of experience, okay, I have observed that these, I'm not saying that all the questions will come from this only. I am giving a suggestion that when you are ready, when you are studying RCC, please concentrate more on LSM, shear, loss of pre-stressed, and IS 456. Definitely, if there is a question from RCC, this is the broader limit where you should be very focused. Now, actually, when I'm talking about loss of pre-stress, my dear students, when I talk about the loss of pre-stressed concrete, we called PSC is pre-stressed concrete, my dear students. We have different losses. First one we have is elastic shortening of concrete. First one we have is elastic shortening of concrete. First one is what, my dear students? First one we have is the elastic shortening of concrete. Second one we have is the shrinkage of concrete. Next one we have is the shrinkage of concrete. Next one we have is creep of concrete. Creep of concrete. And we also have relaxation of stress in steel. Okay, I'll explain you all these things also. Relaxation of stress in steel. So when I talk about this, so these are the 4 losses. Remember, my dear students, are you getting me, my dear students? These 4 losses are observed both in pre-tension. These are observed in both in pre-tension as well as post-tension. These are observed both in pre-tension as well as post-tension, my dear students. So here what I would like to tell you here is there are two losses. There are two losses like frictional loss, or if you talk about the anchorage slip. Remember, this is very important in IES point of view, okay, as well as in GATE point of view also. When they ask you which two losses are specific to post tensioning, remember the frictional loss and the anchorage slip, both two losses are specific to post tensioning. Okay. Now see students, here I would like to tell you one more important thing. When I talk about the loss due to elastic shortening, the loss due to elastic shortening is given by the formula. My dear students, the loss due to elastic shortening is given by the formula M into FCM. Sir, most of my previous students have done this mistake, my dear students. I would like to tell you very important. FC is the stress at the level of steel. Most of the students will take stress at the level of extreme fiber, but please keep a note, FC is the stress at the level of steel. It is the stress at the level of steel, and FC is given by the formula P by A plus PE square upon I. Because see my dear students, here why E square came is because you are telling it is at the level of steel. Please underline this students. The loss due to elastic shortening is given by the formula MFC. What is M? You already know. M is nothing but the modular ratio. M is nothing but the modular ratio. Sir, what do you mean by elastic shortening is when a pre-stressed concrete beam is subjected to pre-stressing force, a shortening of concrete takes place. Due to that shortening, a loss is observed. That loss is known as elastic shortening. And how much is the elastic shortening is given by the formula M into FC, where M is the modular ratio and FC is the stress at the level of steel. I hope you are clear. Next, sorry students. Okay, next one we have is the, one second student. One second. Okay. Now we have the loss due to shrinkage of concrete. Loss due to shrinkage of concrete. Now see students, the loss due to shrinkage of concrete is given by the formula. The loss due to shrinkage of concrete is given by the formula shrinkage strain upon Young's modulus. The shrinkage strain is given for pre-tension as 3 into 10 power minus 4, and for post-tension it is 2 into 10 power minus 4 upon log 10 into T plus 2, where T is the age of concrete in days. This is the value for post-tension. Sir, this is the strain value. Shrinkage strain formula. This is the for pre-tension formula. So what I would like to tell you, what is shrinkage? Sir, when you put a water in a cotton cloth, when you put a cotton cloth in water, what will happen to the cotton cloth? The cotton cloth gets shrunk. So what here I would like to tell you is the loss due to shrinkage of concrete is given by the formula shrinkage strain into Young's modulus. And remember, the shrinkage loss, this is a very, very important point. The shrinkage does not depend upon the application of load. It depends upon the humidity of the atmosphere, and the shrinkage can affect due to how the means based on the method of concrete or the material of cement or aggregate. So this is the loss due to shrinkage of concrete. And we have another formula, loss due to creep of concrete. What is creep? Creep is nothing but long-term deflection under constant loads. The loss due to creep of concrete is given by the formula phi into M into FC. This is nothing but the loss due to elastic shortening, where phi is a factor which is called as creep coefficient, where creep coefficient is defined as the ultimate creep by elastic creep. Okay. Next, relaxation of stress in steel. Next one we have is the relaxation of stress in steel, my dear students. When I talk about the relaxation of stress in steel, my dear students, I would like to tell you one important thing. This is a relaxation which is like, if they tell you the yielding stress is 0.5 Fy, the loss will be 0. If they tell you the yielding stress is around 0.8 Fy, okay. and it will be around 90 MPa. Sir, why they have not given? Actually, from 0.5 it will be given, sir. Okay, 0.5, 0.35, 70, 90. Okay. Now see, sir, the losses are given directly, Amma. The losses are given here directly. Just for your idea, I am telling you, sir. Just for your idea, I am telling you, Amma. What I want to tell you here is, so here what I would like to tell you here is, the relaxation of stress of steel depends upon manufacturing of steel. Suppose if the steel is manufactured by Jindal Steel, then the loss due to relaxation will be different. If the steel is manufactured by Tata, the relaxation of stress in steel will be different. But the relaxation in stress in steel depends upon the yielding stress, that is Fy. If you see the loss due to friction, Amma, the loss due to friction, remember, sir, this is very important. The loss due to friction is given by the formula P naught into mu alpha plus K into X bar, where P naught is the pre-stressing force, loss due to what is the loss due to friction? The loss of pre-stress due to friction. Now you can write that P naught is the pre-stressing force, mu is the coefficient of friction, alpha is the cumulative angle in radians. What is mu, amma? Mu is nothing but the coefficient of friction. Okay. And alpha is the cumulative angle in radians. Alpha is the cumulative angle in radians. Am I clear, my dear students? Alpha is the cumulative angle in radians. Okay. And one more thing, my dear students, K is known as the wobbling constant. K is known as what, sir? K is known as the wobbling constant. X bar is the length of the span. X bar is the length of the span. Sir, why this frictional coefficient is specific to post tension means, if you consider a post tension member, Amma, when you introduce a duct, tendon into this duct, along this length, you will have an interaction between the duct and the wire. That we call the wobble effect or length effect. That is the reason loss of pre-stress is specific to post tension. When you do this tensioning, if you release the tension, there will be a loss due to slip, and the loss due to slip is given by the formula Es into delta L by L. This is the loss due to what, sir? This is the loss of pre-stress due to anchorage slip. This is the loss of slip due to anchorage. Clear, sir? Is it clear, my dear students? So I hope you are clear with all the losses of pre-stressed. And remember, there are 4 losses, even though there are 2 additional losses in post-tension. But if you consider overall losses, the losses in pre-tension will be more when compared to post-tension because of the operation and all. So remember, there are 2 sessions a month. There are 2 things which are very important. The 2 things are pre-tensioning and post-tensioning. Losses like post-tensioning, frictional loss and anchorage loss are specific to post-tensioning, and remaining the 4 losses, that is elastic shortening, shrinkage, creep or relaxation, is specific. It is observed in both pre-tensioning as well as post-tensioning. Okay. Now please see this question, sir. Please see this question quickly, Amma. Okay. Can you see this? Now see, students, here this is very important, Amma. The loss of pre-stress is given by the formula P naught into mu alpha plus Kx bar. The loss of pre-stress is given by this formula. Okay, but he is asking the percentage loss. When they ask you percentage loss means it is nothing but delta P by P naught into 100. Okay, so from this formula, you can write that whatever mu alpha plus K into X bar will be into 100 will be your loss of pre-stress. Okay, so here coefficient of friction, here if you see, the coefficient of friction is given as how much, Amma? 0.3. and x bar, that is length of the span. What is x bar, amma? Length of span. What is mu? Mu is nothing but the coefficient of friction. Okay, mu is coefficient of friction, and x bar is the length of the span, that is 10 meter. X bar is nothing but what, sir? X bar is nothing but 10 meter, that is length of the span. And we have the next one is K. K is wobbling constant. That's what I told you. Length effect or wobbling constant. When I talk about wobbling constant, it is equal to how much, my dear students? It is equal to 0.0015. Now, when we have the section here is C, student. The tendon is in a parabolic tendon. So to find out alpha, what is alpha? I told you cumulative angle in radians. What is alpha? Cumulative angle in radians. Sir, how do you find out this cumulative angle in radians? Means if this is a parabolic tendon, so there can be theta here and there can be theta. So alpha can be written as theta plus theta. But what is the generalized equation of parabola, my dear students? If you see in structural analysis, you might come across this in 3-hinged arcs and 2-hinged arcs. The standardized generalized equation for parabola is y is equal to 4h by L square into x into L plus. So when I do the slope, dy by dx is equal to 4h by L square into L minus 2x. But at ends or at supports, x will be equal to 0. So 4h by L. So for small values, this will be tan theta. For small values of tan theta, this will be equal to theta. Okay, this is the basic calculation, amma. So this will be equal to 4h plus L plus 4h by L. The alpha will be equal to 8h by L. What is h, sir, here? Height, that is nothing but eccentricity. What is h means? Here h is nothing but the eccentricity, right? H is nothing but the eccentricity, and L is the length of the span. So alpha is equal to 8 into 50 mm and length of the span is 10 meters. So it can be taken as 10,000 mm. So this is 50 mm. So alpha is equal to how much, students? Alpha will be equal to 0.04. Alpha is equal to how much, my dear students? The alpha value is equal to how much, sir? 0.004. So when I talk here, the loss of prestress delta P into P naught into 100 is equal to what, sir? Mu alpha plus K into X bar. This is a shortcut I am telling you. Into 100. What is mu, sir? Mu is nothing but 0.03 into 0.04. Alpha is how much, sir? What is the value of alpha? You got 0.04. So 0.04 plus K is how much, sir? K is nothing but 0.0015 into X bar is 10 into 100. So this is the percentage, sir. You will get a value of 0.012 plus 0.015 into 100. That will be equal to 2.7 percentile. Any doubts in this, my dear students? The loss of prestress due to post-tensioning is observed only in post-tensioned members. So this is how you have to solve the problem. So remember, I am telling you again, the loss due to elastic shortening is given by MFC, and the loss due to shrinkage is given by ESC into Young's modulus, and loss due to friction is given by the formula P naught into mu alpha plus Kx bar. This is friction, amma. And if you ask the loss due to anchorage slip, ES into delta L by L. So this is came from self weight. Delta L is equal to PL by AE. From that only it has been derived. Is it clear, sir? I hope you are clear. Now see, there was another beautiful question, amma. There was another beautiful question, and it was the previous gate question also. A simply supported concrete beam of rectangular cross section. What, sir? A simply supported rectangular concrete beam of span how much, sir? Of span is 8 meter. The simply supported rectangular concrete beam of span 8 meter is pre-stressed with an effective pre-stressing force. So what is the effective pre-stressing force, amma? The effective pre-stressing force you can say is 600 kilonewton. Sir, one more point I would like to add before the problem. Sir, see, Sir, some people will ask you, when the cable is tensioned from one end, it will be P naught, amma. If suppose if the cable is tensioned from both ends, this P naught will be taken as P naught by 2. Please remember, this is very important. Okay, I would like to add this point also. In the problem, if the cable is tensioned from one end, we take it as P naught. If the cable is tensioned from both the ends, we take it as P naught upon 2. Am I clear, my dear students? Am I clear? Am I clear, my dear students? So this is a very important point, and keep a note of this point, my dear students. So here the span is 8 meter, amma, with an effective pre-stressing force of 600 kilonewton. The eccentricity is 0 at supports and varies linearly at the midspan in order to balance a concentrated load. So see here, there was a beam, amma, there was a pre-stressing beam. This is a pre-stressing force. A simply supported see, here you have a force. See, here you have a pre-stressing force, and there is a tendon in rectangular way. This is theta, and it is also theta. It is pre-tensioned. Sir, see, remember, my dear students, again please see the question. A simply supported concrete beam of rectangular cross section is 12 kilonewton, right? It has to be, see, having span length is how much, sir? The span length is 8 meter. The span length is 8 meter, my dear students. When I tell you the span length is 8 meter, okay, with an effective pre-stressing force is how much, amma? The pre-stressing force is 600 kilonewton. Okay, now the tendon is 0. It is because it is a linear profile. I told you, no, the tendon is 0 at supports, and how much it is, and varies with a linear value at midspan. In order to balance the external concentrated load of 12 kilonewton, the required value of E. What is the value of E? So here we'll discuss this point very clearly, my dear students. Okay. So here what I would like to tell you here is, there is a pre-stressing beam, amma. Okay, first of all, this is the neutral axis, and we have the pre-stressing cable is theta, 0 at supports and 0 at supports. So here we have a load that is 12 kilonewton. Here we have a load, how much, sir? 12 kilonewton, and here we have a pre-stressing force. So if I resolve these forces, amma, if I resolve these forces, if I resolve this, you will get so if I take here, one thing is sure, sir, you will have a force due to one thing here, and you will have. So can I write that this is one is this force? Sir, are you getting me? There will be a vertical force due to this, and this will be P sine theta, vertical force. And due to this also there will be P sine theta. So you can clearly say that 2P sine theta is equal to 2P sine theta is equal to what, sir? 2P sine theta is equal to 12 kilonewton. Or you can say the value of sine theta, okay, 2P sine theta is equal to 12 kilonewton. We'll, because due to balancing number. This is one point I would like to add. Now, what is tan theta, sir? Tan theta is equal to what, sir? E upon L by 2. E upon what, sir? L by 2. Now, what is E? You can write E, you don't know. E upon L by 2 is how much, amma? The span length. What is the span length? Are you following, my dear students? Can you please respond? What is the span length, sir? Span length is nothing but 8 meter by 2. So this value will be E by 4 meter. This is in meter, amma. Please go. Now, what is 2P sine theta? Sine theta is given by the formula 2P is equal to 12 kilonewton divided by 2 into 600 kilonewton. 2 into 600. So 12 cancel. Sine theta will be equal to 0.1. Remember, my dear students, for smaller values of theta, sine theta can be taken as tan theta. For smaller values of theta, sine theta can be taken as, because cos theta will be 1. So for smaller values, cos 0 is 1. So for smaller values of theta, sine theta is approximately equal to tan theta. So here tan theta is equal to 0.01 upon E upon 4 meter. So E will be equal to 0.04 meter, or you can write, my dear students, 40 mm, or you can write 40 mm. Any doubts, my dear students? I hope you are clear with these concepts. With this, I am done with the RCC part. I have given you the type of the questions, how to revise this. I hope these sessions are helpful for you. Please remember, as we are inching towards the GATE exam, consistent preparation and consistent short notes is very important to grow for you. And remember, practice, practice, practice. Make your short notes comfortable. If you find any difficulty in RCC, stick a board in your room or anything. Make a formulas and make the chart and stick to your board, stick in your room or anywhere, or you make it as a WhatsApp status, or you make it as a screensaver. So in this way, how best you can do, you have to perform. So all the best for you, all the best for my dear students. I hope you have enjoyed these sessions with RCC. I'll try to be more best in geomatics in the coming 29th and 30. Thank you everyone. Thank you.